Hi there and welcome to the R for Data Science exercise walkthrough. My name is Thomas and today we're looking into Chapter 5, Data Transformation in the Section 2, Filter Rows with Filter. I already went ahead and copied these exercises into RStudio, and let's start with doing some prep. So we will need the dplyr package in order to use the filter function, so let's load that first. And then we also need the NYC Flights 13 package, which contains the flights dataset that we will be using in these exercises. And I'm not too familiar with the datasets, so what I'm going to do is $flights in order to display the help page, which will come in very handy because it has this format section here where you can see the various column names that are in the dataset as well as a kind of human readable description. So starting off with the first one, find all flights that had an arrival time of 2 or more hours, or an arrival delay actually. So if we scroll down a bit, we will find this variable here, ARR_delay. And we can see that it's the arrival delay in minutes. So in order to get the flights with an arrival delay of 2 or more hours, we need those with an ARR_delay greater than or equal 120. So let's see what we get. Filter, flights, ARR_delay greater than or equal 120. And we see we get around 10,000 records. And just to put that in perspective, the whole data set has substantially more records, which is a good thing, because if this number would be much smaller, then there would be quite a lot of flights delayed. Anyway, next up, second question, which flights flew to Houston, either the IAH or the HOU airport? So again, if we scroll down a bit here, we have this dest column. So that's the destination airport. So what we need is filter, flights, and then dest double equal, very important, IAH, and then we use the vertical bar, the logical OR, and then once again dest double equals HOU. And sure enough, I did a typo. It's not flitter, it's filter. And we can see that around 9,000 flights went to this destination airports. Next up, which of the flights were operated by either United, American, or Delta Airlines? So if I recall correctly, yes, we have the carrier column in the dataset, and it tells us that this is just a 2-letter carrier abbreviation, and we have to look at the airlines dataset in order to get the actual name. So let's do that. Print out airlines, and fortunately for us, this is a very short dataset, so we can rather easily spot the airlines. So we can see the first one here being American Airlines is AA. We have Delta Airlines, DL, and finally we have United Airlines, UA. So what we can do, filter, flights, 1F is enough here, and then carrier, and this time I will not use the double equal sign and the vertical bar. Instead I will use the in operator, so that's %in%. And then on the right hand side of that, I will put a vector of values that would match the condition. So that means AA, DL, and UA. And we can see almost 140,000 records match that condition. So in this case, the in operator came in extremely handy, because if we would not have used it, it would be carrier double equal AA, vertical bar carrier double equal DL, vertical bar carrier double equal UA. Kind of a lot of boilerplate. So if you check for multiple values, the in operator is extremely handy. So don't forget that one. Next up, we are asked to find those flights which departed in summer, so either July, August, or September. Now looking at the columns here, we can see there is a month column. And I'm not too sure how this is actually coded, whether that's short names for the months, the whole long name, or maybe just numbers. And so in order to do that, I will take a quick look. I will use the head function to print me the first 6 values. And I will do that not for the entire data set, but actually only for the month column. And we can see we get integers back. So 1 being January, 2 then being February, and so forth. So then in order to get the flights that departed in summer, we will use filter, flights, and then month greater or equal 7, and month less than or equal 9. And we can see 86,000 records, meaning 86,000 flights departed in summer. Next up, which flights arrived more than 2 hours late but didn't leave late? So now we're getting into more complex conditions. So starting off, as always, filter flights. And now we have the arrival delay being more than 2 hours. So remember that this is saved in minutes in the data set, so we need greater than 120. And then a logical end, the ampersand, but didn't leave late. So the departure delay is less than or equal 0. And let's just have a quick look if that makes sense. Yes, it does, because it tells us that negative times represent early departure, and an early departure is certainly not leaving late. So that should work out just fine. And it does, and we can see that only 29 records in the data set match this condition. So we're getting almost to the end. Number 6, which flights were delayed by at least an hour but made up over 30 minutes in flight? So what does it actually mean? So their arrival time was 1 hour too late, but their departure time actually was more than 90 minutes late. So if you leave the starting airport 90 minutes late, but then you arrive only 60 minutes late at the destination, then you made up over 30 minutes in flight. So filter, flights, arrival delay less than an hour, so less than 60 minutes, and departure delay. So in order to make up over 30 minutes, this then needs to be greater than 91, if I'm not mistaken. And we can see that 82 records match this condition. And if my logic was wrong, please let me know in the comments, because actually I'm not sure if it is. So last up, which flights departed between midnight and 6 a.m. inclusive? So we need some time columns here, and we have a departure time column, and it tells us that the format is HMM or HMM. So let's have a quick look at the data. Again, I will use the head function, flights, $, departure time. Okay, so that would here indicate 5 a.m. and 17 minutes and so forth. All right, then filter, flights, departure time, well, greater than or equal 0, because midnight would be 0, yes. And it's inclusive. And departure time less than or equal to 600. And we can see around 9,000 records match that condition. Whew, so that was a lot of filtering for one video, and I will leave it at that. The other exercises of this section I will leave for the second part of this video. Until then, happy programming.